Once I've added an inverter and a load profile to my what if usage scenario, I can add panels and batteries. In the previous example, we created this copy of No Solar called No Solar Copy. We're going to edit that now and add our panels. Previously, we created the load profile, a standard load profile with the 6,000 kilowatt usage, and we defined an inverter, and we called it inverter 1 with 2 MPPT ports. So now we can add panels simply by clicking on the panels, using the button in the bottom right to add the panels. We need to give the panel a name because we're going to have 2 strings of panels. So I'm going to call this panel front. Okay, in this string of panels, we have 7 panels, each with a kilowatt peak of 325. We're not optimizing these panels. I'll come back to that at another time. We are connecting it to inverter 1, and we're going to use the MPPT port number 1 from this. There were 2 available. So I can save that. Now I need, as you can see, solar data, and it reminds me that I need solar data. In order to get the solar data, I must first edit to enable the button at the bottom and then fetch the data. I can specify latitude, longitude, azimuth and slope, and what I have here is absolutely fine. It's pointing southeast with a slope of 24 degrees, and I'm going to download and save that. This is fine, it's succeeded in doing that, and I can go back, and shortly I will see the bar chart for this data, so I'll save that. Next, I want to add a new string of panels. So I'm going to edit this, use the button in the bottom right to add it, select the new panels, give it a name. In this case, I'm going to call it back. And the number of panels will be the same. It's still not optimized. And in this case, inverter 1 is correct, but the connected port is MPP2. This is important because if the 2 strings were connected to the 1 panel, so the 1 MPPT, but not optimized, then the algorithm in the simulator would select the best of the 2 strings at any given time. It wouldn't add them. If you use optimized, then it adds all the panels together. This helps when you have panels in different orientations going to the same MPPT. Okay, so I need to now fetch, I'll save this, and then fetch and update the data. And in this case, I want to have it pointing southwest. So I'm going to go for 210 degrees. So I'll download and save that. And it did that quite quickly because I had a previous example was using the same orientation, so the data was downloaded already. So I go back and I can see that I have bar chart indicating that solar data is present. So I save that and I am done with my panels. So when I come out of my panels and go back to the scenario overview, the simulation will happen. The simulation is indicated by this progress bar at the bottom. And when it has done that, it then gives me a best cost because I have cost defined. It provides me with a self-consumption. It provides me with a self-supply. It still tells me that the entirety of my load went to the house because, of course, I haven't defined any load for either hot water or EV charging. And finally, it tells me where my PV went. My PV went primarily about 50-50 to the house and to the grid. That's all I want to say about panels, except when you define panels, you get a tick mark. And when you add data, you get a sun indicator. You need both in order for the simulation to work. The simulation wouldn't have worked if we just defined the panels without the data. Thank you for listening.